Hello class. Today let's go over a few problems from section 2.2. Now exercise number 1A. It is asking in which interval function is increasing, decreasing and remains constant. So here if you notice function is increasing here and after that until here it starts decreasing and from here again it starts increasing and from here it remains constant. So basically for those things we have to write in the interval notation. You guys already know interval notation, that means we are talking about domain or we are talking about x. So now here this is 0, 1, 2, 3. So from all the way to negative infinity to 3 function is increasing. So increasing negative infinity to 3 and another part of increasing here is also increase, here decrease, right, and here increase. Now in between 1 and let's count 1, 2, 3 all the way to 4. So from union another piece is from 1 to 4 it is also increasing. Now for the decreasing part there is just one piece, function is decreasing. For the decreasing part from 3 to 1. So from 3 to 1 it is decreasing, and if you see after 4 it remains constant. So the constant function is constant after 4, that means 4 to infinity. Now here I think I made a typo. So this should be negative 1, this should be negative 2, this is negative 3. So for that reason, increasing all the way from negative infinity to negative 3 and 1 to 4, this part is correct. Decreasing all the way from negative 3 to 1, and the constant from 4 to infinity. So it's all about writing the behavior of the function in the interval notation. Now here we have to, for the test of symmetry, basically if you read this information, for the y-axis symmetry, basically what you do, you replace x by negative x and end up with the same thing. For the origin symmetry, you replace x by negative x and y by negative y and end up with the same thing. For the x-axis symmetry, you replace y by negative y, and if you end up with the same thing, that will be the case. We say function has that kind of symmetry. But you already noticed in the x-axis symmetry, the graph is not a function. That's why you don't see that many problems for the x-axis symmetry. Now here, in the problem number 2, we want to check whether a function is symmetric about y-axis, x-axis or origin. Always I'm going to start replace x by negative x first. So y equals to replace x by negative x squared minus 1. So we end up with x squared minus 1. Is that the same equation? It is. That's why it is symmetric about. Let me write symmetric about. Symmetric about y-axis, because if you replace x by negative x and end up with the same thing, you call it symmetric about y-axis. Replace y by negative y. Negative y equals to x squared minus 1. Divide both sides by negative sign. So y equals to negative x square plus 1. We did not end up with the same equation. That's why it is not symmetric about x-axis. Finally, if you replace x by negative x and y by negative y, let's see what happens. X by negative x and y by negative y. Negative y is equals negative x squared minus 1. So we got negative y. This equals to x squared minus 1. If you divide both sides by negative sign, we got y equals to negative x squared plus 1. So it is not symmetric about origin either. Not symmetric about origin. That's the process we follow. For number B, replace x by negative x. We will get y to the power 5 equals to negative x cubed. It's not the same equation, so it is not symmetric about y-axis. Replace y by negative y. Negative y to the power 5. This equals to x cubed. So this it is negative y to the power 5 equals to x cubed. Divide both sides by negative sign. So we got y to the power 5 equals to negative x cubed. It's not the same as we had at the beginning. So it is not symmetric about x-axis either. Now finally let's check. Let's replace x by negative x and y by negative y. I'm going to squeeze here. Negative y to the power 5 is equals to negative x to the power 5. Negative y to the power 5 equals to negative x to the power, oh that's not 5, huh? 3. So that is 3. Divide both sides by negative sign. So we got x to the power 5 equals to x to the power 3. We end up with the same equation. So it is telling us symmetric about origin. So if you summarize, it is basically replacing x by negative x, y by negative y, and both x by negative x, y by negative y at the same time, and whether we end up with same equation or not. That is the mathematical idea, to see the graph of the function is symmetric about x-axis, y-axis, or origin. Now here, some idea about how to decide whether function is odd or even. Now even function, it is symmetric about y-axis, and then the odd function means symmetric about origin. So here this function is symmetric, so it is even function. This function is symmetric about origin, that's why that is odd function. This function is symmetric about y-axis, that's why it is even function. Same story, this is also even function. Now, square root function. Here, this function is not symmetric about y-axis, it is not symmetric about x-axis, it is not symmetric about origin either, so it is neither. This function is symmetric about origin, so that's why it is odd function. Same story here, so this is also odd function. Now here, if you see this graph is symmetric about origin, that's why it is odd function. This rational function, if you see, this is symmetric about y-axis, that's why it is even function. Logarithmic function does not have any kind of symmetry, so it is neither. Exponential function also does not have any kind of symmetry, that's why it is this function. If you see, it has symmetric about the origin, that's why it is odd function. In the trig function, you will learn in the pre-calc. Here, if you see, this function as symmetric about the origin, that's why it is odd function. Now here, if you see, this function has symmetry, has a symmetry about that line, that's why it is even function. And here, this function has symmetry about this point, that's why that function is odd function. So let me recall, symmetry means if this function is even function, so that means if you rotate the graph along that line, you end up with the same graph. That is the meaning of the symmetry. You can see from that way also. Now, how we determine this function is even, odd, or neither? We will follow the same idea. Let's replace x by negative x. F negative x, this equals to negative x squared plus 6. So it is x squared plus 6. We end up with the same function. That's why it is symmetric about y-axis. If it is symmetric about y-axis, then it is even function. Let's replace g in g. Let's replace x by negative x. 7 negative x to the power 3 minus, replace x by negative x. So we got negative 7x cubed plus x. We don't get exactly the same, but pretty close. So if you multiply this function, g negative x by negative, let's see what happens. This becomes positive 7x cubed, and that becomes negative x. Exactly the same thing. That's why this function is odd function. This is just a mathematical way to see whether function is odd or even. For number C, if you do the previous idea, none of the idea will give the same expression. That's why this function is neither. Now let's go over the another problem, exercise number 5. How we should understand the piecewise function? If the input is in between 0 and 60, we have to use this expression. If t is bigger than 60, then we have to use this expression. That is the meaning of piecewise function. So C40 lies on the first interval. That means C40 is simply 20. Now C80, which is bigger than 60, that means we have to use second function. That means we have to put 80 for t. So 20 plus 0.40, t is 80 minus 60. 20, order of operation, we take care of parenthesis first. 0.40. If you subtract, that will be 20. Let's multiply first. So 20 plus use your calculator. I think that will be 8. So we got 28. Now the next thing we will do is how to graph piecewise function. Now here, okay, we do have grid on the another side. Let me copy the function. F of x equals to 1. X equals to x if, when you go back and see the information, less or equal than -2 and bigger than -2. So we are talking about two pieces. So -2 is here. Now let's what is it telling us? F of x equals to 1, always constant if x is less than -2. Height is 1, so it is always constant and -2 is included. That's why solid circle. So that is the graph on that piece. Now in the another piece, if x is bigger than -2, it is x. So let's choose couple of values. If x equals to 0, f of 0 is 0. For 0 it is 0, so I'm going to put that value. If x equals to -1, f of -1 is, x is -1, so -1 here. Now the question is how far we have to extend. 2 points are sufficient to draw a straight line. So on the right hand part, no problem. For the left hand side, you want to be very close to -2, but not cross -2. So that's why I want to put open circle. So that is the graph. So did you notice we do have two graphs in the two pieces? That's why this kind of function is called piecewise function. Now for the last problem from this section, how to find fx plus h? Simply we replace x by x plus h. So 2x plus h square minus 3x replaced by x plus h. So let's simplify. 2, this is x plus h times x plus h minus, let's distribute 3, that gives 3x minus 3h. Let's do the FOIL on the first part. 2, x times x is x squared, x times h is xh, h times x is xh or hx, h times h is h squared, minus 3x minus 3h. Let's FOIL 2, or maybe we can combine x squared, the middle two terms, 2xs plus h squared. Guys, did you notice if we know a plus b times a plus b formula, it will be short, but here we are not using that formula. If you know how to use that formula, you can write the expression directly. Now let's FOIL. Let's distribute. 2x squared plus 4xh plus 2h squared, in fact, h squared minus 3x minus 3h. Is there anything we can combine? It seems not. So we leave like that. So that is the final answer. On number B, we have that subtracting the original expression. So 2x squared plus 4xh plus 2h squared minus 3x minus 3h. That is fx plus h we got from part A. Minus fx is we got 2x squared minus 3x divided by h. So we put everything there. this we have to simplify. So 2x squared plus 4xh plus 2h squared minus 3x minus 3h. Let's distribute negative sign. That gives negative 2x squared but positive 3x divided by h. 2x squared cancel out. 3x also cancel out. Now on the top we do have 3 terms left, and among them h is common. H we can factor out. If we factor h out, here we are left with 4x, here we are left with 2h minus 3 divided by h. This h cancel out. So we end up with 4x plus 2h minus 3. That is the final answer. And you will be happy because you will be doing this thing in business calculus or calculus quite often.